Good afternoon. I'm Matt Cooper, and I am presenting on interbasin water transfer with the Energy Exascale Earth System model. Nearly half of New York City's drinking water is provided by water that's stored in reservoirs in the upper Delaware River Basin. And that water is transferred via the Delaware Tunnel Aqueduct out of the Delaware River Basin into New York City. And that water would otherwise flow along its natural course along the Delaware River to the Delaware Bay, where that fresh water keeps salinity in the estuary at safe levels and prevents the salt front from migrating inland, where it can threaten the freshwater intakes for cities like Philadelphia and Trenton and for other important needs in the Delaware River Basin. But that type of interbasin water transfer is rarely, if ever, included in climate model simulations. So we examined the water storage capacity of reservoirs in the Susquehanna and Delaware River Basin and found that just 2% of reservoirs, or 35 reservoirs in total, control 80% of the storage in this region. So we selected these 35 reservoirs and added them into the E3SM computational mesh as elements that are linked to the computational river flow lines. And that will enable us to include the storage and release of water from reservoirs in the E3SM Mozart water management model and the transfer of water across basin boundaries to, in this case, New York City. We analyzed historic records of river discharge in the Delaware River and found that when the river discharge is low, it pushes the salt front position in the estuary inland. And that relationship is the strongest in the driest months. And we combined this statistical relationship between river discharge and salt front position with historic records of New York City water withdrawals to analyze how New York City water withdrawals affect the position of the salt front. And we constructed two counterfactual scenarios, one where New York City withdraws no water, shown in blue, and one where New York City withdraws its maximum allowable water in yellow, and found that under historic climate, that New York City withdrawals are already capable of moving the salt front inland towards unmanageable levels, last seen in the record drought of 1965. So we'll use the new capability enabled by the E3SM computational mesh to study how these dynamics play out under future climate scenarios as part of the Integrated Coastal Modeling Project, funded by the United States Department of Energy. And I'd like to thank the Pacific Northwest National Laboratory and DOE for funding this work, and for all of you for attending, and please contact me with any questions.